Next topic is launching of satellite. First of all, what is a satellite? Satellite is a body which continuously revolves around a much huge body comparatively in size in a fixed orbit. Now, satellites are broadly classified into two categories by which you will actually get the meaning of satellite. Satellites are either naturally existing or called natural satellites, or they are artificial satellites which are actually man-made, right? So, which is the natural satellite of Earth? I said that satellite is a body which revolves around in a fixed orbit continuously around a much larger body. So, satellites must be some body for which revolving motion is performed or is given by some external force or some internal force, right? That means some force is definitely required. So natural satellite for Earth is, we all know that it is moon, and artificial satellites in India, there are a lot of these artificial satellites which are launched these days, PSLV, GSLV, INSAT series, there are many, right? So right now we are going to understand the concept of launching of satellite. How do we launch a satellite and what are the necessary conditions for it? See, first of all, I'll explain you this by giving a proper example of, suppose this is Earth, okay, and we make a very tall tower on its surface. It's like those towers on which our radio communications are made, right? Some kind of that tower. Here we are standing like you guys and me, okay? I throw a stone from this point, suppose this is me. I throw a stone from this point, it will obviously fall by after covering some distance. It's like a parabolic path which we did in kinematics, the motion in 2 and 3 dimension, right? Suppose I throw it with all my strength. So see, this is something very imaginary because compared to distance of Earth or compared to size of Earth, my size is obviously negligible. But just to make you understand this concept, how do satellites revolve in a perfect circle, that's what I'm explaining. Suppose this time I throw the stone with all my strength, and this time it will fall by covering a bit more distance. Suppose you and me together implies all the force which we can and throw it with much larger force, and this way it will cover more distance, but ultimately it will fall to Earth pertaining to its gravitational pull, right? So that means the horizontal velocity which we are giving us to the body which we are throwing, that horizontal body is actually accounted for covering this distance which body is traveling, right? Now there must be some velocity at which if the body is thrown, it will escape the gravitational pull of the object, right? Or the gravitational pull of Earth. So that time this maximum velocity is so much that it tries to fall on the surface of Earth every time, but it misses it every time. So what exactly is happening right now? How do any object continues to be in state of circular motion? Is there any external force or some other force responsible for the proper occurrence of circular motion? Yes, there is a force, and we know that force by a name called centripetal force, right? For example, Earth is revolving around Sun due to gravitational pull of Sun. That means centripetal force is provided by gravitational pull of attraction. Secondly, if I tie this marker with a string and rotate it, so the revolving motion of this marker in that case is given by what? The centripetal force is provided by the tensional force obtained in the string. Lastly, electrons move about the circular orbits about what? Neutrons which are contained in the nucleus. So that time also the circular motion or the centripetal force is provided by electrostatic force of attraction. So we have discussed this point before as well, that every time whenever there is a circular motion, the centripetal force must be existent and that force will be provided by something. So in this case, this was the Earth or the planet about which the satellite is taking the circular path or revolving around it. So its velocity must be something so that it tries to fall on the surface due to gravitational pull, but it every time misses the pull. So here what is happening? The gravitational force of attraction is balanced by the centripetal force which is required for the body to be in circular motion. So centripetal force is provided by gravitational force. What is the formula for centripetal force? We all know that this is mv square upon r. So this is my distance, the radius, which is r, and this is the distance, which is capital R, okay, which is the radius of Earth, and this r is the height at which the satellite is revolving around this planet. V, what should be the V? V is V naught. V naught is actually the orbital velocity required for this body to perform such kind of motion. So mv square upon r is equal to, what is gravitational force? G capital M, let us say the mass is m here and small m here. G capital M small m upon, what is the distance? R square. So we can cancel out this thing and single r. What I am left with is V naught is equal to Gm over r, or V naught is equal to under root Gm upon r. This formula can be remodified by another thing. We know that acceleration due to gravity is what? Gm upon r square. That means Gm is equal to small g multiplied by r square. If I put this value of g into m in this formula, I'll get V naught is equal to under root what? G r square upon the single r, small r, which is the total height at which the orbit is there, or the total height at which satellite is revolving. One r goes out of the root. I am left with g over r, or r times g upon, what is this r? This is the radius plus the height. Basically this is the height at which the orbit is revolving around, the satellite is revolving around the planet. So from this formula of orbital velocity, or sometimes teacher call it orbital velocity, sometimes they call it orbital velocity, both are correct, there is no difference. We are just transforming from a British accent to American accent, okay. So orbital velocity, even by this formula or that formula, you can clearly see that this orbital velocity is independent of the mass of the satellite which is projected. So that is why no matter what is the mass of the vehicle, for example PSLVs are very highly dense as compared to GSLV vehicles, but again mass of satellite is independent in the value of orbital velocity. So that is why the launching of satellite entirely depends on gravitational pull of the planet, radius of the planet, and the height at which this satellite is going to revolve around the planet. We can do one more thing. We can put the values of the g, r and h if we consider that, suppose the minimum height at which the satellite is revolving about this planet, let us say h, which is very less than r. Let me rub this board and let's do this calculation.